Okay, let's wait for another 30 seconds for others to join, and then we will be starting with our questions and all. Okay. Okay, then we are going to start questions from work, power, and energy. We have done some one or two questions in the previous class. So in this class, we will be taking up largely this one, and then we will be discussing some questions from the rotation, basic one, that will help us in other topics as well. Okay. So the very first question is there on your screen. Done. It's visible. I guess. Yeah, it is. Okay. So take some 3 minutes of your time and do it. 3 minutes starts now. Okay. Be careful. This is a multiple choice question. Okay. Is are true. So first read the question carefully and then move step by step ahead. The question is quite easy. You just need to be careful with what the statements are, and accordingly you move. Whatever you're getting, let me know through the chat box. Okay. Yes, that's true. Once that's correct. Any other options? Yes. Yes, that will be true also. Very good. Anything else? So let's see now what the thing is. What is given here? A particle of mass m is initially at rest. Done. So mass m is here, and at t equal to 0, its velocity is given at 0. Done. It is subjected to a force and start moving along the x-axis. Because of that force, it starts moving in x-axis. It's a positive, like it's kinetic energy. Yes, once correct. Very good. So its kinetic energy is given as dk by dt equal to gamma t. So here you will be writing dk by dt equal to gamma t. Done. Which of the following statements are correct? Done. So kinetic energy is given here. That is rate of change of kinetic energy is directly proportional to time here. Now from this we have to check if speed status is what, and what force look like, and what is the distance of particle from the origin after after changing time, with changing time, sorry, and if the force acting is conservative or not. So the very first thing, kinetic energy can be related with velocity, right? Kinetic energy can be written as what? Half mv square. We can write like this now. Done. So k d by dt of what we can write? Half mv square, and that will be equal to how much? Gamma t. Done. Clear here. So here you will see that differentiation of v square, dv square by dt can be written as what? Half m into 2v into, you will be writing what? Into dv by dt. And that is equal to how much? This is your k is equal to half mv square, that we can write now. If you're getting confused, you can write like half mv square. Done. So kinetic energy I have written as half mv square, and if you're going to differentiate this half mv square, what you will be getting? Half mv dv by dt, and that will be equal to how much? Gamma t. Now, if you see here carefully, this is what? mv dv equal to gamma t dt. Done. So something like this. Now integrate it. So if you're going to integrate it, what value we are going to get? Initial velocity is 0, final velocity, let it be v. Initially time means t equal to 0, and final time we are going to take as t. So if you're going to solve it further, what you will be getting here? So you will be getting something like m is constant. So v dv का integration क्या हो जाएगा? mv square by 2 with proper limits taken. And now gamma t dt will be equal to t square by 2, some constant, something like that. No, here we have already put the limit, so this will be our value. Now, if velocity we calculate here, then velocity will be equal to what? T by something m. Done. So velocity is this. It means velocity is what? A speed of particle is proportional to time. Yes, it is proportional to time. So B is the correct option. Now, force on the particle. So if we have velocity with us, we can easily calculate force. Because force is what? Mass into acceleration. If velocity is there, acceleration we can very easily calculate. And what is acceleration value? That is dv by dt. Velocity is what? T by m. So if you're going to differentiate t by m, you will be getting what? 1 by m. So acceleration is what? Constant. So if acceleration is constant and mass also is constant in the question, so force applied will be what? It will be constant. Done. Now we will also check C, but let's check first D. So the force is conservative or not. How to find out how to see that if force given is conservative or not. So for that, let me actually it will be B actually, then not C. Suppose just a concept I'm giving. Suppose force is given as x cube y square I cap plus y cube x square j cap. Something like this is force is given, and you are asked if this force is conservative or not. So what is the way to check actually? If with calculation we want to check, then it will be dfx by dy should be equal to y differentiation of y component of force with respect to x. This should be equal. If this is equal, then this force is conservative. If not, this force will be what? Non-conservative, right? And if you just think that if force is a constant, if force is constant, then definitely dfx, fx, fy, there's no concept of that here. So whatever force, suppose this is some value 2 Newton. So its differentiation with respect to x with respect to y is going to be what? 0. So whatever constant force you're going to encounter, and if question is asked like it is conservative or non-conservative, so we can say that it is what? Conservative. Done. So in the question, we have got a constant force, and that constant force will be what? Conservative. Done. Now let's check C, the distance of particles. So distance we have to check. What was the velocity? Velocity was something like t by m. Done. So this can be written as dx by dt equal to t by m. So dx, x initially 0, x t by m dt, initial time always 0. So x equal to how much we are going to get? T square by 2m something. So x is not changing linearly with time, it is changing non-linearly with time. Because x is not directly proportional to time, it is directly proportional to t square. So what the option was? Distance of particle from the origin increases linearly with the time. No, it's not increasing linearly. So this option is what? This is wrong. Correct option is what? A, B, and B. Okay. I hope it is clear for everyone. Now let's go ahead with the question. Again, just read the question carefully. If read and be logical, be more creative in this question. Take some 3 minutes of your time and do it. देखो सोचना है ना, सोचना ही अभी तुम्हारे लिए बहुत जरूरी है. In every question you need to give your thought. If you're giving your thought, you are actually learning. If not, you are not. Done. So even if question is not getting solved till last, doesn't matter. If you are giving it thought, you are learning, and that learning will help you in the exam. Because class के बाद you need to practice more and more questions. So this will be helpful in that. चलो ठीक है. So think about this and do it. This question I included because I wanted you to think a bit. चलो सोचो और बताओ क्या होगा. अच्छा, once. Condition for conservative force. I told you now, if force is given something as a function of x, y, kind of this, done, and it is asked that if force is conservative or not. So there is a rule for that. Just in the previous class, I told you the rule to calculate equilibrium points. And if that equilibrium point will be stable or unstable. So we were doing double differentiation kind of thing and checking that. So similarly, there is also a concept for finding out the nature of force. If force is given, done. So here I have taken an example. Force is x cube y square I cap plus y cube x square j cap. So j cap. So my force is having two components, this and this. Done. So if dfx by dy equal to dfy by dx, then fx कंपोनेंट ऑफ फोर्स को लेना है आपको और उसको y के रिस्पेक्ट में डिफरेंशिएट करके देखना है. अगेन y कंपोनेंट ऑफ फोर्स को लेना है और x के रिस्पेक्ट में डिफरेंशिएट करके देखना है. इफ दे आर कमिंग इक्वल, फोर्स विल बी कंजर्वेटिव. अगेन यहाँ पे x z के टर्म में हो सकता है, x z. डन. तो अगेन फोर्स को दूसरे एक कंपोनेंट को दूसरे वेरिएबल के टर्म में डिफरेंशिएट करके चेक करोगे. ठीक है, समझ रहे हो? And if that is coming equal, the force will be what? Conservative. Otherwise, force will be what? Non-conservative. Again, if force is constant, for the constant force, you can easily see that differentiation will come 0. No matter what variable, with respect to what variable you are differentiating it. So that value you are always going to get 0. So constant force can always be taken as conservative force. Done. I hope it is clear. Okay. So आप ये क्वेश्चन जल्दी से ट्राई करो. चलो. इसमें ज्यादा कैलकुलेशन करना नहीं है, बस अच्छे से सोच लेना. चलो डन करो. Check once more. Once. यहाँ पे क्वेश्चन में एक पॉइंट और है कि other than that at A, first collision that happened at A, that you have to neglect. Okay, make the proper counting. Once opposite जा रहा है, but they are moving in a circular trajectory now, so somewhere they will meet, right? अच्छा ठीक है. Let me take up the question. So what the question is here, there are two small particles of equal masses. Done. This is particle 1, this is particle 2, moving in opposite direction from point A in a horizontal circular orbit. Done. Their tangential velocities are v and 2v. Done. As shown in the figure, between collision, the particle move with constant speed. It is moving with constant speed. Obviously, velocity will change because direction of speed will change. After making how many elastic collision? Collision happening again is elastic. Okay? Collisions other than that at A, these two particles will again reach the point A. Just imagine at A, both are here colliding. One started moving in this direction with a speed v, and another started moving with this in this direction with a speed 2v. Where they will meet? Done. So one is traveling with a speed v, another is traveling with a speed 2v, and they are moving like this. One started from A, both started from A. One is moving in this direction, another in this direction. Done. So they are moving like this. Now what will happen? Where they will meet? Suppose at t time they are meeting. Suppose at t time they are meeting for the first time. So distance covered by first particle, that is with one with moving with velocity v. I'm calling this first particle, this as second. So how much distance will it cover, vt, and how much distance this second particle will cover, 2vt. and distance covered by both the particle added together, distance I'm talking about, that will be equal to 3vt, and that will be equal to how much? 2 pi r. Done. So after how much time they will meet? They will meet after 2 pi r by 3 time. This much, after this much time they will be meeting. Done. So in this time, first particle will cover how much distance, like in that t time, first particle covered how much distance? Okay, 3vt equal to 2 pi r. So t equal to 2 pi r by 3v. Done. So how much distance first particle will cover? That will cover your vt distance, yani ki 2 pi r by 3. And second will cover how much distance? That will cover 2 into 2 pi r by 3. So this is in term of distance. If you see very closely at it now, how much angle first is covering? For calculation of angle, simply we will divide it by radius. है ना? जैसे in one complete rotation, a particle move how much distance? 2 pi r. How much angle? 2 pi r by r, that is 2 pi. So in t time, at the time of first collision, first particle has covered how much distance? 2 pi r by 3. So how much angle? 2 pi by 3. 2 pi by 3 का मतलब कितना हुआ? This is your pi by 3 is 60. 60 into 2, that is your 120. So first particle is somewhere here. It has covered 120-degree angle, and rest 240-degree angle will get covered by which particle? Second particle. So first and second particle will collide first time, for the first time here. And this collision is what kind of? Elastic. And you know, in elastic collision, if bodies are having equal masses, here masses of two bodies are what? Equal. And you know that if collision is elastic and the bodies are having equal masses, then during collision, they will exchange their velocities. Done. So what will happen here? At first collision, particle 1 will take the velocity of second, and second particle will take up the velocity of first. So second particle after first collision will definitely change its direction of velocity. In this direction, it will start moving. With what velocity? With velocity v. And first will start moving in this direction with what velocity? 2v. तो चलो अब मैं यहाँ पे बनाती हूँ. So what was the first collision वाला position? If चलो इस एंगल को 120 मान लेते हैं, यहाँ पे collision हुआ. Done. So after first collision, first particle started moving in this direction with 2v and first with velocity v. Now we don't need to go into the calculation. First calculation only we will be using. How? So one moving with 2v velocity will cover how much angle? 240 degree. So 240 degree angle will be 120 was this. That will be 240 or how much? Yes, that will be 240. So how much angle? How much angle now first particle is going to cover? First particle is going to cover how much angle? 240 degree. So suppose it has covered 240 degree and it reached here. And in that time, how much angle first particle will cover? 120. Then that will happen. So second time they are colliding at where? Second time they are colliding here. Done. And here what was the velocity of first particle? Its velocity was 2v, and velocity of first particle was how much? V. So now what will happen? Now this was second now. This was second particle, this was first. First particle was having velocity 2v. At this time, what will happen? Again, exchange of velocity will occur. So first particle will now start moving in this direction with velocity v, and second particle will start moving with velocity 2v in this direction. Done. Now, one moving with the velocity v will cover how much distance? How much angle? 120 degrees. So that will come at A. And second one, whatever it was, it will cover how much angle? 240. So again, it will come at A. So after second collision, they will again meet at A and collide again. So after how many collisions except at A, if we deduct collision at A, then after how many collisions they are meeting? After 2 collisions. Did you get my point? किसी को doubt है? है तो बताओ। अच्छा, डाउट है या नहीं है, समझ में आ गया या फिर कुछ डाउट है? नो का मतलब, यस का मतलब मैं समझी नहीं एक्चुअली। कोई डाउट है किसी को? नो डाउट। ठीक है, चलो ठीक है, डन। विदाउट वेस्टिंग टाइम लेट्स मूव अहेड नाउ। सो दिस इज अ क्वेश्चन अगेन फ्रॉम सेंटर ऑफ मास थिंग। चलो करते हैं इसको। तो आई एम गिविंग you again here some 4 minutes of time. Just look at the question carefully, read it. Question is very easy. Again, you just need to be careful with readings. Take reading properly of the question and after that solve it. चलो करो। If any doubt you are getting in between, you can ask me. You can send your doubt in chat box. Multiple options are correct here. Look at that carefully as well. चलो डन। let me discuss them. So what the question is, there is a block of mass m, then this bigger block has a mass m, then and it has a circular cut with a frictionless surface as shown. And this is the circular cut made in the block of mass m. Then the block rests on a horizontal frictionless surface. Its friction coefficient is what? Mu0 hai. Initially, the right edge of the block is at x equal to 0. So this is termed as x equal to 0. A point mass m is released. Now there is a point mass here. Then and its mass is how much? M, small m. Is released from rest at the topmost point of the path as shown, and it slide down. When the mass loses contact with the block, like when it will lose contact, मैंने यहाँ से इसे block नहीं बनाया है. This point particle will come here, and if it moves even a little further from this point, it will come down to the frictionless surface. It means it will leave the block. Done. So when the mass loses contact with the block, its position is x. Its position is what? X. So, and its velocity is v. At that instant, which of the following things are correct? Done. So the velocity of point mass m is this. Option is like this. X component of displacement of center of mass of the block m. So block n का center of mass जो है वो कितने distance से shift हुआ है? That's the question. The position of point mass m is this, and whatever is like that. So how to deal with this question? Very first thing. So how we deal with, जैसे first hand ना question को बहुत ही carefully से देखो. Question क्या था हमारे पास? Question ये था कि हमारे पास एक block है and it has mass m, and this block has a small mass, small point mass m kept at top point. Yes, once that will move now. It's movable. Because in the option you can say see like that. It's movable completely, and also it is on frictionless surface, no? So if it is on frictionless surface and it is experiencing even a little bit of some internal force, that I will explain here. So what is happening here? There is just a block of mass m, and this is a point mass. Now just imagine in the center of mass thing you have studied. कि सपोज कर लो हमारे पास क्या है, एक ऐसा प्लांक है, डन, और यहाँ पे एक ब्लॉक ऐसा है, डन. सिंपल में ऐसा ही एक सिस्टम लेती हूँ. दिस इज द सिंपलेस्ट सिस्टम दैट आई कैन टेक टू एक्सप्लेन दिस. तो सपोज कर लो मैं इन दोनों को एक सिस्टम मान रही हूँ. अगेन इन सेंटर ऑफ मास काइंड ऑफ क्वेश्चन ऑन इन रोटेशन, सिस्टम आइडेंटिफिकेशन इज वेरी इंपॉर्टेंट. Which one you are considering as a system? So here in this example, I have considered this plank and this ball as a system. Means whatever is beyond this plank and ball, that will be external to the system, but this ball is the part of system and this plank is the part of system. Now imagine what happens if this ball started. Chalo, before that, let me tell you, कि suppose center of mass of this plank is here and center of mass of this ball is here. Okay, two dotted point I have kept. So center of mass of the system means plank plus ball will be somewhere here. Suppose it is somewhere here. That, so this is center of mass of the system. Now what I am telling now, I am telling that this ball is moving in this direction. So this ball started moving with respect to the plank. Again, this is an internal motion. Because this ball is the part of system. Done. So this ball started moving towards this. So if this ball start moving towards this, what will happen? Its center of mass of ball is moving closer to the center of mass of plank. Then center of mass of the system will shift. Done. Center of mass of system will shift. But it should not shift because center of mass shift when center of mass shift, when external force is acting on the system. Done. Center of mass shifting कब होता है? When external force act, and external force means force acting outside the system. And here if ball is moving, ball is applying force on the plank, done, while moving. But this force won't be taken as external force because this ball is the part of system, because I have considered ball and plank as a system. So whatever force ball is applying on the plank because of its motion, that will be internal force. And because of internal force, no center of mass shifting will happen. And if center of mass is remaining here only, so if ball is shifting this direction, then plank will shift in this direction to maintain the center of mass at this point. Agree? So that will happen. This is a very important concept to pick up here. Done. So center of mass का चलो मैं फॉर्मूला ही दिखाती हूँ. Center of mass का फॉर्मूला आप क्या लिखते हो? You write like something, अगर x direction में लिखना है तो m1 x1 plus m2 x2 divided by क्या लिखते हो? Sorry, not whole divided by m1 plus m2 लिखते हो ना? Done. And shifting in center of mass, suppose I am going to write. So partially I am going to differentiate. So change in center of mass will be equal to m1 delta x1 plus m2 delta x2 divided by m1 plus m2. That I can do now very easily. So this thing I can do now. If this is permissible, you can see here, if center of mass is not shifting, no external force acting, means delta xcm will be 0. So if it is 0, it means m1 delta x1 will be equal to minus of m2 delta x2. Agree? This will be true. So this is the equation that we needed to use here in this question. How? So for that, we need to choose our system very carefully. So which one I'm going to consider as a system? You just see here, Planck body of block of mass capital M has a point particle of a small m that is moving on its surface. So if we consider m plus m as a system, then because of the motion of this particle, small m particle, this capital M mass will experience some kind of force, and that force will try to move this capital M mass. By what distance? That we need to check. Okay? So you just see here, the moment a small m is coming here, by what distance it has moved? It has moved by a distance capital R. Done. So one mass is moved by distance capital R. By what distance another mass will move? So when capital M mass will move now, with that small m mass will also move, because small m mass is riding on the capital M mass. Done. So the moment small m mass will reach here, this whole system will get shifted slowly in this direction also. Done. So if I'm going to apply this formula here, because no external force is acting, shifting of the one mass, that is, chalo main likhti hu, theek hai? Let's see it very wisely. So shifting of a small mass ko main pehle likh rahi hu, m, that got shifted by R, will be equal to shifting of another. So another shifting mein dusre ka bhi shifting ho ja raha hai na? When capital M mass will move in this direction, together with that small mass M will also move in that direction. So what I'm going to now write, what should I write here? I should write here M plus M X. Done. So by what distance capital X, capital M mass is going to move? It is, sorry, minus sign will be here. So it is going to move mr by m plus m. By this distance, it will move. Okay? So, sorry. So let's see the question here. X component of displacement of center of mass of block M. So block M ka center of mass kitne distance se move kiya? So that we have calculated. Correct? Any problem in this?
No, ma'am.
Okay, thank you. So if not here, then let's go on to the velocity wala part. So how we can calculate now the velocity? So just concentrate on that portion also. I have taken system as what? M plus M. So just see, no external force is acting, right? So if no external force is acting, no friction is there, energy will remain conserved, right? So energy is remaining conserved. Now just see, just before a small m mass started moving, just before that, yani ki initially, what was the energy of my system? System means capital M plus M. So capital M has no energy, but here this is taken as the x-axis and this is taken as the y-axis. And here point mass M is kept at what height? At what height it is? It is at a height of like initially it is at a height of this, and finally it is coming at this height. Then finally it is coming at this height. So if I consider this height as 0, h equal to 0, this height as 0, then what will happen? There may be a doubt in your head कि capital M का center of mass कहाँ होगा, मतलब उसका y height change करेगा या नहीं? So its y height will not change now, because for capital M there is no vertical direction motion happening. Done. So its potential energy, gravitational potential energy will remain what? अच्छा, class lag हो रही है क्या? Each words not clear? सोम तो बोल रहा नहीं. Who is this? Vivo something. Please यार अपना नाम तो लिखा करो so that I can quote your name. Might be network problem with you. हाँ, आपका नाम क्या है? अच्छा, बीच बीच में रुक रहा है क्या? Might be network issue from my side also, but I want to know. Once ऋषभ नितिन बता दो जल्दी से यार, so that we can move ahead. चलो ठीक है, मैं बोलती हूँ अगर कहीं पे प्रॉब्लम होगा मेरी वॉइस में तो प्लीज एनीवन लेट मी नो. अच्छा ठीक है ऋषभ, थैंक यू. सो व्हाट इज हैपनिंग हियर? एनर्जी में हम लोग थे ना. सो चलो मैं दूसरे पेज पे जाती हूँ, देन आई विल ट्राई टू एक्सप्लेन. सो व्हाट इज हैपनिंग हियर? यू जस्ट सी दिस M block is where it's on the horizontal surface and it is moving horizontally. There is no vertical motion happening for it. So its gravitational potential energy is not going to change. But the small particle was here. It is moving downward like this. So during this motion, it is moving horizontally by this distance, vertically by this. Done. So its gravitational potential energy is changing. So only we will be dealing with the gravitational potential energy of this small mass M. Done. So let's now see what will be the initial energy of the system. So initially there was no motion, no kinetic energy, only potential energy. And initial potential energy of the system will be what? That I will be only considering for small m. So what I am going to write? I am going to write how much? चलो मैं यहाँ पे लिखूंगी इसको, ठीक है. सो रेफरेंस पॉइंट मैं कौन सा ली हूँ? h इक्वल टू 0 मैंने इसको लिया है. So initial height was of a small mass m will be how much? R. So initial energy of the system is only mgr. No other energy is there. Now, finally, what will happen? Finally, what will be the energy of system? So finally, this capital mass M will also have velocity. So suppose कर लो कि capital mass M has velocity v2 with respect to ground, and small mass M has velocity v1 with respect to ground. Just I have made it more simple. With respect to ground, I have taken. Done. So final kinetic and final potential energy of a small mass M will be 0 because h0 height it has reached. And finally, only the system will have kinetic energy. How much? Half m v2 square plus half m v1 square. Again, let me explain here more. v2 I have taken with respect to ground. अगर मैं velocity को small mass m की velocity को अगर Planck के respect में लूं तो calculation lengthy हो जाएगा. Done. क्योंकि Planck here or block here has also some velocity, so that will like become more lengthier. We will have to calculate it more and more and more. So जब भी तुम्हारा दोनों चीज का मोशन हो रहा हो, you have to make the calculation simple, and if it is possible to take velocity with respect to what? With respect to ground. ठीक है. प्लैंक की पोटेंशियल एनर्जी मैंने जीरो की ना वंस. क्यों किया मैंने जीरो? क्योंकि प्लैंक का कोई मोशन नहीं हो रहा है वर्टिकल डायरेक्शन में. अगर तुम्हारा सपोज कर लो मैं यहाँ पे एक सिस्टम ले रही हूँ, ठीक है. सपोज कर लो इसका हाइट यहाँ है, ठीक है. तो इसका इनिशियल पोटेंशियल एनर्जी क्या होगा? अगर ये h हाइट है और मैं इसको h0 मान रही हूँ तो इनिशियल होगा mgh. सपोज ये मूव इधर कर रहा है, देन so it moved here and went here. Again इसका सेंटर ऑफ मास का हाइट तो सेम है ना, so its potential energy is not going to change. So better let's not write it, क्योंकि initial potential energy will be equal to final, it will get cancelled only. That is why for Planck I have not taken potential energy into consideration. Okay, now kinetic energy I'm talking about. So this is this. Again, we have to calculate V1 and V2. V1 is given or what? No, nothing is given. So we have to calculate V1 and V2. So for that, we need one more equation. And one more equation we can very easily write. Which one will be that? You just see here, I have taken M plus M as a system. And on this system, no external force is acting. If no external force is acting, we can always conserve momentum. Again, very important concept. Conservation of momentum applies when no external force is acting on the system. So here system is my M plus M. So its initial momentum was how much? Its initial momentum was 0 because system was not moving. Small m started moving. Finally, it is here. Okay. Final position is when small m has reached this point. Done. So finally, what will be the momentum? This block M has a velocity v2 with respect to ground I have taken. So it will have momentum in this direction towards left, and a small mass M will have momentum in this direction. How much? V M, a small m into v1. So initial momentum is 0 of the system. Final momentum should also be 0. So whatever momentum capital M mass have, that momentum must be equal and opposite to whatever momentum small mass M has in the horizontal direction. Done. So that well explained can be written as mv2 equal to mv1. Clear है? Now this is done. अब हमें क्या निकालना है? अब आप इसका values निकाल लो. If you're going to calculate that, you will be getting A as correct. Okay, you just need to solve both of those questions. Sorry, both of those equations. Now C में क्या दिया हुआ है? The position of point mass is. तो ये तो आप easily निकाल सकते हो ना, क्योंकि I have already calculated the position of what? I have already calculated the position shifting of capital mass M. I have calculated its shifting now. So from there you can easily calculate ki jaise initially x, this was 0 na, x equal to 0. Finally, where has small mass m reached? Here. Done. So it has reached at x equal to 0, but it has also got shifted somewhat in this direction because of shifting of capital mass m. Done. So you can tell now what will be the position of this small mass m. Done. So that you can calculate, and if you will be calculating, you won't be getting this. Velocity of block M, that again you will be getting from here. That won't be equal to that actually if you will be calculating. Done. So the correct option will be A and B. So if you have calculated B, you will be calculating C. If you have calculated A, you will be calculating D. Done. And all I have discussed. Chalo. So this question was a good question actually. We needed to discuss so many things. सबसे पहला चीज इसका टेक अवे क्या होगा? आइडेंटिफाई सिस्टम. ठीक है, सिस्टम को केयरफुली आइडेंटिफाई करो टू मेक द क्वेश्चन मोर इजियर. अगेन, इफ एफ एक्सटर्नल इज 0, मोमेंटम क्या होगा तुम्हारा? कंजर्व होगा. दैट वाज द वेरी इंपॉर्टेंट थिंग. इफ एफ एक्सटर्नल इज 0, देन डेल्टा एक्स सीएम विल बी व्हाट? 0. Shifting, no shifting of center of mass. And these two were the two important concepts that you needed to apply here. And third one was conservation of energy, that you have been doing since long. Chalo. Okay. So if you want to take deep breath, you can breathe for some 1 minute. And after that, this question is very beautiful, very simple question again, but lamba dikh raha hai. पढ़ना पड़ेगा थोड़ा सही से. So I'm giving you all 4 minutes. Read it carefully, have some water, relax, and after 1 minute, try. Question easy है, ठीक है? So we have already discussed what? तुम्हारा क्या-क्या discuss किया था हमने? Projectile motion we have discussed, right? So that will have application here. Question is easy. Read it. किसी को doubt है तो बताओ. होप सबका हो रहा है. Yes. Correct. Quadratic equation you will get for calculation of time. Yes, correct. Shall slow down. Okay. Chalo, should I explain? Time is up actually. Some 30 or 35 seconds past it. Should I wait? Should I move? Once. One minute. चलो ठीक है. Time का value actually you will be getting in integer only. So you might be going wrong somewhere, I guess. No worries. चलो ठीक है. No worries. So what the case is actually, what is happening? There is a car P and that is moving with a uniform speed 5√3 meter per second. If some speed is just given, it's not explained with what respect it is given, then we assume that it is given with the respect of ground, right? So the car P is moving with respect to ground with a velocity of 5√3 meter per second towards a carriage of mass 9 kg. And here there is a carrier car or something kind of. Let us call it B. So B has a mass of 9 kg and it is at rest on the rail at point B. Then the height AC is, this height given is how much? 120 meter. Cannonballs of 1 kg are fired from the car. From here, cannonballs are being fired at an angle of 30 degree with the horizontal. The first with a speed, what? 100 meter per second at an angle of this. Again here, mark the speed. This speed is not given with the respect of car P. it is simply written that its speed is 100 meter per second. It means its speed is given with respect to ground only. Had it been given like speed is 100 meter per second, or it is being fired with 100 meter per second with respect to car, तो ये कार के रेस्पेक्ट में वेलोसिटी होती है इसकी. Done. Then we for ground calculation we would have calculated its velocity of cannonballs with respect to ground. How? This would have been equal to velocity of cannon with respect to that car P plus क्या करते हैं यहाँ पे velocity of P with respect to ground. कुछ ऐसा करते है ना? But it's directly given 100 meter per second means it is with the respect to with respect of ground. So nothing to worry about. So the very first thing is first cannonball hits the stationary carriage after a time t naught and sticks to it. So t naught time में ये यहाँ से यहाँ पहुँच गया. Done. So first we have to calculate t naught. How we will calculate t naught? Just go to the projectile motion. So if projectile in how many types of projectile you must have studied? One तो तुम्हारा होता है ground to ground, means we are throwing from the ground and it is coming back to the ground. So this is ground to ground projectile, and for this projectile all the formulas that we have studied is true, right? Next is your height to ground projectile, means certain height we are throwing ball. Again there are two ways of throwing ball from the height. One is we can throw the ball horizontally, and in that case our trajectory looks something like this. And the second way of throwing the ball that is being done here, कि हमारा ball यहाँ है and we are not throwing it horizontally, we are throwing it at some angle. So what it will do, it will go something like done. So this is third wala case is the case that we have to solve here. For this only we use all the formulas that we have studied. For here, we prefer more to go with the equations. Then we have to calculate here what we have to calculate here time at which it will hit the ground. यहीं पे हमारा carriage है ना. Done. PB कितना दूर है? अच्छा PB कितना भी दूर हो उससे तो कोई फर्क नहीं पड़ेगा क्योंकि हमें उसको कैलकुलेट नहीं करना है. आप देखो ध्यान से यहाँ पे I'm going to do that. Even if PB is not given, you don't need to worry about. क्योंकि हमें क्या निकालना है? Time of flight, T naught निकालना है. अब देखो T naught कैसे निकालेंगे? मेरा बॉल इनिशियली कितने हाइट पे था? Initially, if you see at what height was the cannonball? 120 meter. So here I am going to write 120 meter. And finally, when it is landing, it is covering how much height? 120 meter down it is going, right? So this height is 120 meter. Now, if I'm going to calculate its, if I write its velocity in x direction of cannonball, तो आप क्या लिखोगे? 100 cos 30 लिखोगे ना? 100 into √3/2 लिखोगे. uy क्या लिखोगे आप? uy लिखोगे 100 into sin 30, that is your what? 50 होगा meter per second. Unit I'm not writing here. Acceleration in x direction 0, acceleration in y direction. Again downward direction को चलो मैं positive लेती हूँ. So this will become -c. Done. We have to calculate the time of flight. तो चलो मैं y direction के motion को लिखती हूँ. मैं लिख रही हूँ y equal to uyt plus half ayt square. So if in time of flight I am going to deal with, then in time of flight what will happen? My ball was initially here and it is coming here. So how much y distance it has covered? Initially y was 0 and finally here y is how much? -120 meter. क्योंकि in the downward direction we are moving. कार की velocity नहीं add होगी ना? नहीं होगी. That is what I discussed before ना, क्योंकि यहाँ पे क्या दिया हुआ है आप ध्यान से देखो. Fired from the car with an initial velocity of 100 meter per second. Cannon की velocity दी हुई है 100 meter per second. Done. At an angle 30 degree with the horizontal. यहाँ पे ये बात ही नहीं किया है कि 100 meter per second कार के respect में है. If nothing is talked about, then we will assume what it is universally true. If nothing is given about the status of velocity, कि किसके respect में है, तब हम लोग ground के respect में लेते हैं. Done. So अगर यहाँ पे दिया होता कि कार के respect में 100 है, तब हम लोग कार की velocity को count करते. यहाँ पे कुछ नहीं दिया हुआ है, means already it is given with respect to ground, so that is 100. That is why I have taken here 100 only. Done. चलो, so y direction में हमारा velocity क्या होगा, क्योंकि वही यहाँ पे ट्रिक है. कभी कभी क्वेश्चन क्या है ना, हम लोग सीरियसली पढ़ेंगे नहीं तो ऑब्वियसली चीज इसको माइनस करेंगे. डन. प्लस और माइनस जो भी होगा दैट यू विल डू, बट यहाँ पे करना नहीं है. तो y कितना होगा, अगेन प्रॉपर साइन कन्वेंशन आप यूज करना. -120 uy, initial velocity in the y direction is in upward direction. How much? It is your 50. So here 50t plus लिखूंगी. Ay is how much? That is your 10t square. Something like this we are getting, right? So 2 5, अगर 5 5 हर जगह से कट करो तो यहाँ पे क्या कितना बचेगा, -24. This will be 10 and this will become 1. चलो t square को मैं इधर लाती हूँ. So t square minus 10t minus 24 equal to 0. Now let's solve it. So t equal to how much? We can break it like, yes, -12t plus 2t minus 24 equal to 0. So if you are going to solve it, you will get this. I know time can't be negative, so t equal to -2 is incorrect. T will be equal to how much? T will be equal to not 64. It will be equal to, t will be equal to 12. See carefully, t का value क्या आने वाला है, 12 seconds. So t naught is how much here? T naught here is 12 seconds. Done. So for calculating the time of flight, we always write y equal to s equal to ut plus half at square wala equation in the y direction for calculation of time of flight. Done. For calculation of maximum height, what we do at maximum height, for maximum height calculation, we use formula v square equal to u square plus 2as again in the y direction for maximum height. And maximum height wala jo formula padhe ho na, that also we can use in all these three kinds of projectile motion. ठीक है, that is only universal. फिर time of flight निकालने के लिए हम लोग क्या करते हैं, time of flight निकालने के लिए v equal to u plus at वाला formula use कर सकते हो. Done. Yeah, no worries. Avoid silly mistakes only. ठीक है, तो इस तरह से हम लोग सॉल्व करेंगे. t नॉट तो मिल गया. चलो अब नेक्स्ट पोर्शन में चलते हैं. Assume that the resistive force between rail and carriage is constant and ignore the vertical motion of carriage. यहाँ पे जो ये है ना, इसका vertical motion को आपको क्या करना है, इग्नोर करना है. अगेन चलो इग्नोर कर दिया हमने कि ये वर्टिकली मूव नहीं करेगा. डन. एंड resistive force between rail and carriage is constant. इनके और इनके बीच का रेजिस्टिव फोर्स भी क्या दिया हुआ है तुम्हारा, कांस्टेंट है. डन. इग्नोर करना है वर्टिकल मोशन को. इफ द सेकंड बॉल आल्सो हिट्स एंड स्टिक्स टू द कैरेज, व्हाट विल बी द हॉरिजॉन्टल वेलोसिटी ऑफ कैरेज जस्ट आफ्टर द सेकंड इंपैक्ट. So after second impact, what is going to be the velocity of this B? That is our question. So the very first thing that I want here to discuss is, यहाँ पे देख लो हमारा प्रोजेक्टाइल कैसे था, कुछ इतने हाइट पे था ना, और यहाँ पे आकर गिर रहा है. सो इफ यू केयरफुली रिमेम्बर ना, तो हमारा अगर तुमने इस प्रोजेक्टाइल को भी देखा होगा तो तुम्हें पता होगा कि इफ वी आर सेंडिंग इट लाइक दिस, इट विल आल्सो लैंड लाइक दिस. Same angle it will make with the horizontal, the angle that it was making here. Done. Because no resistive force is acting in between motion na. In air resistance we neglect. So no resistive force, it means at whatever orientation you have sent the projectile, at same orientation it will land. Done. So like this. Again, same thing will be true here. It is getting sent like this. So when it is going to land here on the cart, that B is here, so there its horizontal velocity of cannonball will be equal to the initial horizontal velocity. Then we have only to deal with the horizontal thing, क्योंकि vertical motion of cart is being neglected here. Then so यहाँ पे जो ball गिरा, जो cannon गिरा, this cannon will have horizontal velocity of how much? Ux will be equal to 50√3. So just before collision, the horizontal velocity of cannonball is how much? 50√3. So just see the case here. Cart is, चलो मैं cart को यहाँ draw करती हूँ ऐसे, ठीक है. So this is B. It is at rest. So its initial momentum P cart is equal to 0. इनिशियली, डन। और इनिशियल मोमेंटम ऑफ, चलो इसको बी लिखते हैं, ठीक है। इनिशियल मोमेंटम ऑफ कैनन बॉल, initial just before the collision in x direction we are dealing with, right? Because this card can move only in the x direction. Now initial momentum of cannonball kitna hoga? Mass of cannonball into velocity in the horizontal direction, that was 50√3. Done. So this is the case with initial momentum. Initial momentum total is how much? M into 50√3. Now finally what is going to happen? This cannonball will stick to it. So finally system में क्या consider कर रही हूँ? Card, this B and cannonball. So initially system का momentum ये है, finally both are getting stuck together. So इन दोनों का अब mass कितना हो जाएगा? You just see the mass of individual one. 1 kg mass था cannonball का और B का mass था 9 kg. ठीक है? So what is this small m? This is 1 kg. So this is 50√3. एंड फाइनली जब ये कंबाइन हो जाएंगे तो इनका मास कितना हो जाएगा? 10 kg. डन. सो फाइनल वेलोसिटी सपोज कर लो इनका v है, फाइनल वेलोसिटी इज हाउ मच? v. सो व्हाट विल बी द वैल्यू ऑफ v? फाइनल मोमेंटम विल बी 10 into v will be equal to initial momentum, that is equal to how much? Yes. So once what will be, this will be equal to 50√3. So this is going to be, v is going to be how much? 5√3 meter per second after first impact. First impact के बाद B का velocity ये होगा in the horizontal direction. Now let's see what will be the velocity of second impact. ठीक है, T तो निकालना था क्वेश्चन में, वो तो हमने निकाल लिया ना। है रब्बा, T is 12 सेकेंड। सो गए हो क्या? ऐसा मत करो। यहाँ पे क्या हो रहा है देखो, सेकेंड इम्पैक्ट के बाद पूछा है ना, तो चलो ठीक है, फिर से इमेजिन करते हैं कि सेकेंड टाइम हमारा कैनन बॉल फिर से आया। ठीक है, जब फिर से आया तो एक काम करो, अब मेरा सिस्टम क्या हो गया? एक कैनन बॉल जो कि मोशन में है और ये कार्ड प्लस कैनन बॉल जो पहला वाला आया था वो, यानी कि हमारा सिस्टम क्या हो गया? 10 kg of this plus another cannon ball that is about to hit. Done. So initial momentum again आप निकाल लो। initial momentum of system क्या होगा? Initially card plus cannon ball का momentum देख लो कितना है? That is equal to, its velocity is 5√3, mass is 10 kg, so that is equal to 50√3. और initial momentum of cannon ball about to hit will be how much? So that will be equal to again 1 into 50√3. Done. So total initial momentum कितना हो जाएगा? 100√3. Now what will be the final momentum? Finally after second impact, second impact के बाद क्या होने वाला है? ये B तो रहेगा ही और इसके पास 2 कैनन बॉल्स रहेंगे। So finally इसका मास कितना हो जाएगा? 9 था, 10 था और एक और आ गया 11 kg. So finally suppose कर लो ये V velocity से बढ़ रहा है। Done. So what you will be writing here? Final momentum of the system will be equal to 11 into V. So 11V will be equal to how much? That will be equal to 100√3. So velocity will be equal to how much? 100√3 by 11. That is your going to be the answer. ठीक है, this is going to be your answer. ठीक है, डन है? क्लियर है सबको क्वेश्चन? एनी डाउट? किसी को डाउट है बोलो।
मैम हम पूछ रहे थे कि आपने जो पहले जो मोमेंटम, मैम ये दूसरी स्लाइड जो आपने सॉल्व की है मैम वो दिखा दी एक बार।
हाँ बोलो
मैम, वो जो सेकंड स्लाइड में आपने सॉल्व किया ना मैम, यहाँ पे जो आपने ये वेलोसिटी जो निकाली 5√3, तो मैम इसका क्या काम है यहाँ पे?
देखो काम ये है ना, क्वेश्चन अगर तुमने ध्यान से पढ़ा तो क्वेश्चन ये बोला था कि एक कैनन बॉल है, ठीक है, एक कैनन बॉल इसको हिट किया पहली बार। डन। तो पहली बार जब हिट किया होगा तो यहाँ पे इस कार्ड का कुछ ना कुछ वेलोसिटी हुआ होगा, है ना। क्वेश्चन में हमसे ये पूछा है, हमें निकालना ये था कि जब दूसरी बार जब कैनन बॉल जाकर हिट करेगा सेकेंड कैनन बॉल, तब इस कार्ड की वेलोसिटी क्या होगी, वो हम कैसे निकाल पाएंगे। वो हमें निकालने के लिए ये पता होना चाहिए ना कि जो मेरा कार्ट है उसका वेलोसिटी जस्ट बिफोर सेकंड कैनन बॉल उसको हिट कर रहा है क्या है। डन। क्योंकि कार्ट इनिशियली तो रेस्ट में है, लेकिन फर्स्ट कैनन बॉल जब हिट किया होगा तो इस कार्ट के पास कुछ हॉरिजॉन्टल वेलोसिटी आई हो, तो सेकेंड बॉल जब इसको हिट कर रहा है उस वक्त इस कार्ट के पास कुछ हॉरिजॉन्टल डायरेक्शन में वेलोसिटी है, दैट यू नीड टू कैलकुलेट ना। ठीक है, चलो डन। कोई डाउट नहीं है, डन है। फिर से तुम लोग इसको ट्राई करना। नाउ दिस इज अगेन अ वेरी इजी क्वेश्चन। शुड आई, चलो ठीक है ये कर लेते हैं एक बार। चलो करके बताओ, बहुत ही इजी है। आई विल बी गिविंग ओनली 2 मिनट फॉर दिस, डू इट फास्ट। वंस क्या हुआ, मैं फास्ट हो गई यार। आई टुक, इफ यू कांट बिलीव, आई टुक सम 10 मिनट्स टू एक्सप्लेन द प्रीवियस वन क्वेश्चन। मैं तो यार फास्ट नहीं हूँ, बट ये टाइम काफी फास्ट जा रहा है मुझे लग रहा है। क्या करूँ यार, आई एम सॉरी बट आई नीड टू मूव अहेड नाउ। आई टोल्ड यू ऑल, ना डाउट हो तो यू कैन कॉन्टेक्ट मी लेटर ऑल्सो, आई कैन डील विद दैट। ठीक है। यस, मेरा मकसद बिल्कुल नहीं है कि आगे आगे चलकर आगे चले जाना। आई जस्ट वॉन्ट यू पीपल टू लर्न something out of it, then only it will be beneficial for me as well. Completing things are not my motto. Completing in the way that it is getting completed by you also is my motto. ठीक है, चलो। हो गया। Done. What answer you're getting? This is not the answer. Just by mistake, this arrow got drawn actually. Neglect that. Avoid it. Okay, what's the answer? चलो ठीक है। वेट करूं, आ रहा है किसी का आंसर? If yes, then I will wait. Yes, correct. चलो कोई नहीं. So ओके, मैं समझाती हूँ. पाई बाई 2, पाई बाई 2 तो नहीं होगा. Somewhere you might be doing mistake. Okay, let's see what is happening. A particle of mass m is projected from the ground with an initial speed u naught at an angle alpha. So it is getting projected with a speed how much? U naught at an angle how much? Alpha. So this is u naught. Its trajectory will look something like this. Then what is happening at that point? One more thing is happening at the highest point of its trajectory, highest point P, somewhere here, it makes a completely inelastic collision with another identical particle. ठीक है, आइडेंटिकल पार्टिकल के साथ एक इलास्टिक कोलिजन, सॉरी इनइलास्टिक, कंप्लीटली इनइलास्टिक का मतलब, कंप्लीटली इनइलास्टिक मतलब कि कोलिजन से पहले दोनों दो चीज थे, आफ्टर कोलिजन दे विल गेट स्टक टुगेदर. डन. सो दैट इज द मीनिंग ऑफ कंप्लीटली इनइलास्टिक, which was thrown vertically upward from the ground with the same initial speed u naught. यानी कि vertically upward फेंका गया, यहाँ से ही फेंका गया होगा, तभी they can meet at the highest point ना. So it is being thrown with a speed u naught in this sense, and it is being thrown with a speed u naught in this sense. ठीक है. So just imagine when they will meet. Will they meet while going up, or will they meet when this will go here and it will be coming down from some top point? When will they meet? So simple चीज है यार, क्योंकि कंफ्यूजन यहाँ पे शायद वही हो रहा होगा. t इक्वल टू क्या होता है? टाइम ऑफ फ्लाइट का फॉर्मूला क्या लिखे हो? 2u/g. ठीक है. फॉर फर्स्ट केस, टाइम टेकन बाय फर्स्ट पार्टिकल टू रीच एट द हाईएस्ट पॉइंट विल बी हाउ मच? हाफ ऑफ द टाइम फ्लाइट. So that is uy/g, यानी कि u sin alpha by g. Half of the like to reach here, it will take how much time? U sin alpha by g. And to reach the highest point, this projectile will take how much time? It will take u naught by g. Then here, all the velocity is in vertically upward direction, u naught by g. So to reach the maximum height, it is taking u naught by g time, and first projectile is coming at this point only in what time? U by g into sin alpha, यानी कि lesser amount of time. Done. So this projectile must be somewhere here while going up only. Done. क्योंकि maximum height तक पहुंचने में तो इसको उससे ज्यादा टाइम लग रहा है ना. So it must be somewhere here just while going up. तो चलो ये तो हमें पता चल गया, यानी कि यहाँ पे जब ये पहुंचेगा तो सेकेंड प्रोजेक्टाइल की वेलोसिटी यहाँ पे क्या हो? यहाँ पे कोलिजन हो रहा है ना. सो एट दिस पॉइंट वी नीड टू चेक की व्हाट विल बी द वेलोसिटी ऑफ टू पार्टिकल्स. तो फर्स्ट का वेलोसिटी किधर होगा? टुवर्ड्स दिस डायरेक्शन होगा, क्योंकि हाईएस्ट पॉइंट पे है, एंड दैट विल बी u cos alpha. व्हाट विल बी द वेलोसिटी ऑफ सेकेंड पार्टिकल व्हिच इज गोइंग अप एट दिस पॉइंट? व्हाट विल बी इट्स वेलोसिटी? दैट वी नीड टू चेक. तो इसकी वेलोसिटी समवेयर अपवर्ड ही होगा, बट हाउ मच? सो यहाँ पे जिस पॉइंट से इसको थ्रो किया गया था वहां पे वेलोसिटी था u naught. एट दिस पॉइंट व्हाट विल बी इट्स वेलोसिटी? सो हाउ मच डिस्टेंस इट हैज कवर्ड? द मैक्सिमम हाइट ऑफ फर्स्ट प्रोजेक्टाइल, दैट मच हाइट इट हैज गॉन अप नाउ. सो व्हाट इज दैट मैक्सिमम हाइट का फॉर्मूला? फॉर्मूला शुड बी इन योर हेड, राइट? सो h max का फॉर्मूला क्या होता है? ui square by 2g. so how much it is? u square sin square alpha by 2g. This is h max now. So this much distance second projectile has covered. Now what will be its velocity? So let's calculate the velocity. How you will be calculating that? So v square equal to u square plus 2as. U square is how much? u naught ka square. Acceleration due to gravity is in downward direction, so minus 2g into s का वैल्यू आप क्या रखने वाले हो? u square sin square alpha by 2g. So 2z cancel होगा ना? Yes. So this is your how much you are going to get u naught square 1 minus sin square alpha. So that is equal to cos square alpha. So v का वैल्यू क्या हो जाएगा? u naught cos alpha. So इसकी वेलोसिटी भी कितनी है? u naught cos alpha. Done. So both the particles are having same velocity magnitude in different directions. Done. So one is going like this, another is going like this. So after collision, they will stick together. No. So initial momentum of the system is in which direction? Just check for the initial momentum of system. System means two particles here taken together. So first has the momentum in which direction? You just see. First has momentum in horizontal direction. How much? M V naught cos alpha. Second has momentum in vertical direction. How much? M V naught or U naught, whatever you call it, cos alpha. So net momentum will be in which direction? Net momentum will be somewhere here in this direction. Done. And okay. So finally, what will happen? These two balls will stick together and they will start moving in this direction, in the direction of net momentum. So initial momentum was in this direction. Final momentum will also be in this direction क्योंकि momentum हमेशा एक conserve होता है. So whatever is the initial momentum, same value will be of the final momentum. So finally, these two balls will move towards the line of initial momentum. That is this. Now, what is this angle that we needed to check? So what was the vertical component of momentum of these two systems? This one system actually. So that was your m v naught cos alpha. And what was the horizontal component of momentum? m v naught cos alpha. So what will be this angle? Y by x tan alpha likhoge na if this is alpha. So y is equal, x is equal. So tan alpha 1 alpha will be equal to how much? 45 degrees. Done. Is it clear, everyone? Yes. A is answer. This is the answer. ठीक है? चलो. ओके. देखो ये क्वेश्चन बहुत ही सिंपल है. अगेन 1.5 मिनट ओनली आई विल गिव. यू जस्ट नीड टू पुट द फॉर्मूला एंड गेट द आंसर. चलो जल्दी से बताओ मुझे क्या होगा. इफ यू रिमेम्बर द फॉर्मूला, चलो अगर भूल गए हो तो मैं बता देती हूँ. Momentum exerted by light value used to be how much? Energy of light by speed of light. ठीक है? The speed is what? Momentum exerted by light, that is u by c. चलो जल्दी से निकाल के बताओ यहाँ पे आंसर क्या होगा. I want answer from everyone. Just let me know. तुम लोग नहीं करने वाले इनर्शिया में चले गए हो क्या? चलो जल्दी से करो. यस करेक्ट. चलो सारे लोग आ जाओ. आंसर का अटेंडेंस लगाओ सभी लोग. Yes. Yes, correct. Chalo, I want everyone to solve actually. यहाँ पे क्या दिया हुआ है, पल्स ऑफ लाइट ऑफ ड्यूरेशन ऑफ pulse, that pulse is how much, 100 nanosecond. Power of the pulse is how much, 30 millivolt. Speed of light is given. Momentum, light is getting completely absorbed. In case of completely absorbed, what will happen? Like फाइनल मोमेंटम ही तो पूछा है ना. इफ लाइट इज गेटिंग कंप्लीटली ऑब्जर्व, तो यहाँ पे और कोई कॉन्सेप्ट की जरूरत नहीं है एक्चुअली. यू जस्ट नीड टू सी कि हाउ मच लाइट इज, how much energy of light is falling over the object. So power is this much, pulse timing is this much. So energy what, power into time लिखोगे ना. And if energy is this, that is u, p into t, तो power कितना हो जाएगा, power sorry momentum कितना हो जाएगा, तो power that is your 30 millivolt. So ये लिखोगे into time, how much, 100 into 10 to the power minus 9 by 3 into 10 to the power 8. So whatever value you're getting here, 3 will get cancelled, and this 10 to the power minus 3 will get cancelled by this 330, and you will get only 10 to the power 17 now. ये फॉर्मूला किसका है? ये फॉर्मूला है तुम्हारा, पढ़े होगे ना 12 का फर्स्ट पार्ट ऑफ एनसीईआरटी लास्ट चैप्टर, इलेक्ट्रोमैग्नेटिक वेव. वहां पे पढ़े हो ना, इफ लाइट इज फॉलिंग ऑन द सरफेस, हाउ मच मोमेंटम इट विल एक्सर्ट. Momentum getting exerted, how much momentum it will exert is u by c, that is energy of light falling by what. नहीं पढ़े, पढ़ना था ना. ये तो है ना तुम्हारा एनर्जी. इफ light of energy u is falling over an object, then momentum exerted is u by c. That is your formula ना. डन है, चलो ठीक है, ठीक है, ठीक है, ठीक है, डन. This is a question that we will be dealing with ahead. Now, what is my strategy now going forward? In rotational motion, I thought to discuss basics in the sense ki you should, what minimum thing you should know to solve all the rotational concept, if that is coming in some different topics like electrostat, in ray optics, or in in magnetism and all. So just basic I wanted to discuss of the rotational motion, that I will be doing in the next class. And some average to easy questions also I will be picking. So my target is not to leave anything. Done. Yeah, thank you. So that is my target. And after that, what I will be doing, I will be giving 3 classes to your modern physics. So modern physics mein, what is going to be my strategy? Again, first class will be like, I will be picking some easy questions, not that much easy, all conceptual questions I will be taking up, but that will hardly take your 1.5 minutes each question. Then why that question? Just to take you through all the concepts, क्योंकि modern physics में याद करना बहुत होता है. So I just want you कि आपका revision हो जाए. So the first class will contain some 20 or 25 or 30 questions. So I will need कि आपकी energy काफी ज्यादा अच्छा हो, so that 30 क्वेश्चन को हम लोग 1.5 घंटे में एक्चुअली खत्म कर सके. ठीक है. So that in the next class only I wanted to, so ये काम मैं और कर सकती हूँ कि next class से मैं modern physics में start करती हूँ this rotation वाला thing. Again I can have in another class जहाँ पे half an hour में मैं इसको cover कर लूँ, but still चलो कल के क्लास में पहले rotation ही कर लेते हैं, just give it a closer, and after that modern physics I will be getting in. Done. और तो first class of modern physics is all about theories revision. Yes baby, yes, tell me.
मैम हम कह रहे थे कि ये मॉडर्न फिजिक्स है वो कितने दिन में, मतलब कब तक खत्म हो जाएगी?
मेरा टारगेट है यार अप टू सैटरडे. टुडे इज व्हाट, टुडे इज योर वेडनेसडे नाउ, सो थर्सडे, फ्राइडे, सैटरडे, बट उसका आधे घंटे तो चला गया तुम्हारा इसमें, क्या है ये, रोटेशन में. सो जो ट्यूसडे का क्लास होगा ना, उसके हाफ तक मॉडर्न फिजिक्स जाएगा, एंड आफ्टर दैट आई विल बी गोइंग फॉरवर्ड टू अनदर चैप्टर्स. यस, सो आई विल बी अपलोडिंग पीडीएफ. पिछले वाले का मिला ना सबको? यस, एनी डाउट?
आप पीडीएफ कहाँ पे अपलोड करेंगी?
ये डिस्क्रिप्शन में होता है यार, वीडियो के डिस्क्रिप्शन में तुम्हें मिल मिल जाएगा, डिस्क्रिप्शन में मैंने डाला हुआ है ना, सारा नोट्स है उसमें, सारा तो नहीं है बट 4-5 है, रिसेंट क्लासेस का है। ठीक है, चलो ठीक है, ठीक है, सो कल मिलते हैं।
मैम
ए इज द आंसर, यस करेक्ट सर। हाँ
मैम हम कह रहे थे कि क्या कहते आपके पास जो फिजिक्स के चैप्टर्स की फॉर्मूला लिस्ट होगी।
यस सोम, हाँ फॉर्मूला लिस्ट है ना, आई विल बी एडिंग दैट देयर आल्सो, डिस्क्रिप्शन में मैं वो भी ऐड कर देती हूँ। ठीक है,
यस मैम।
ओके, यस सोम, यूट्यूब पर जो वीडियो है ना, जो ये वाले क्लास का भी वीडियो तुम देखना, उसके डिस्क्रिप्शन में सारा एडेड है। ठीक है, आप वहां पे चेक कर लो। चलो ठीक है, अगर नहीं मिलता है तो लेट मी नो। ओके बाय, टेक केयर एवरीवन एंड एंजॉय, थैंक यू सो मच, थैंक यू। चलो निकलते हैं अब, बाय बाय, टाटा, टेक केयर। क्यों नींद नहीं आ रही है?